Okay, so we're back. How do you find extreme values? That's our topic right now. Relative extrema can only occur at what are called critical numbers. If f has a relative minimum or a relative maximum at a given point, x equals c, then c must be a critical number for f. That's a theorem, something that we have as a fact. How do you find critical numbers? Well, critical numbers are values of x where the derivative is either equal to 0 or the derivative is undefined. So a little bit of repetition here. We wrote it in a sentence, and then just as a summary, the value of the derivative at any relative extrema, since critical numbers are the locations for relative extrema, are either going to be 0 or undefined. And that's going to help us determine what our max and min values are. So here we have a little recipe. I won't read it off to you. I'm sure you can do that on your own. But we will use it as we start working on some examples. So how do I find the absolute extrema on my function? Here I've got a quartic function. I'm not going to graph it. I'm going to follow those guidelines right above. So step 1 says find the critical numbers. And if critical numbers are where the derivative is equal to 0 or undefined, then what do I need in order to find them? I need the derivative. So my first step, step 1, would be to to take my function and find the derivative. So here that's going to be 4 times 3 is 12, x to the third. And 3 times 4, that's another 12, but this one will be x squared. And I want to determine where that derivative is equal to 0. In this example, I don't have to worry about undefined values of my derivative, because my derivative is a polynomial function. It's never undefined. Its domain would be all real numbers, so there would be no value where my derivative was undefined. Now here, I want to make sure I factor. You don't want to divide by x because x could equal 0, and then that would be, you would lose one of your solutions. So I want to take out 12x squared as the greatest common factor, and that'll leave me with x minus 1. And so my critical numbers are either at 0, that's where x squared would give me my 0, or at 1, where x minus 1 would give me 0. So I have 2 critical numbers in this example. Step 2 asks me to evaluate my function at each of those critical numbers. Notice here I'm looking for absolute extrema. This is my procedure for absolute extrema only. We're going to deal with relative extrema in a later section. So what am I going to do? I'm just going to test, well, what is f of 0 and what is f of 1? This just means you're going back and plugging into the function, right? I probably wouldn't show work in my homework, but here, just because it's my notes, right, I'm going to be a little bit more detailed. So here I would have 3 times 1 to the 4th minus 4 times 1 to the 3rd, and I would get, what, 3 minus 4, or negative 1. Now step 3 is to check your endpoints. Remember my picture on the front side. It could be that a relative extrema is going to give me one of these absolutes. So it could be that my derivative equaling 0 is going to lead me to those, but it could also be a picture like the one on the right-hand side of the front page, where the endpoints are the max or the min. So whenever I'm looking for an absolute extrema, I also test the values of my function at those 2 endpoints on my interval. So I won't write it out here. You can go ahead and plug them in on your own, but I got a 7 for plugging in negative 1. And when I plugged in 2, I got a 16. So that was step 3. Step 4 is to evaluate and determine your answer. Okay? If I'm looking for the highest and the lowest, then what are they between these 4 numbers? My lowest is right here, and my highest was at 16. So that means that I have an absolute minimum value at the coordinate 1, negative 1, and I have an absolute maximum value at the coordinate 2, 16. And so those are my solutions. Always the same procedure. Find your critical numbers, either where the derivative is 0 or undefined. Evaluate your original function at those critical numbers. Evaluate your your function at the endpoints. And then for whatever numbers you've generated, determine the high or low to determine your solution. All right, I'm going to pause here and start another video just for timing.